Alright, let's continue with this problem. Let's look at the information that we have calculated already. We know that R parallel is 3.2. We know that the external resistance is 5.2, and we know that the total effective resistance, external plus internal, is 6 ohms. Then we calculated, or rather you guys calculated, that the current in this circuit at where the ammeter is in is 2 amps, and now they are asking what the reading on the voltmeter is. If you look at this diagram of the circuit, you'll see that the voltmeter is only over one of the resistors in the branch of the parallel part of the circuit. So in other words, as I explained earlier, this whole branch has a certain voltmeter reading, the amount of energy that goes into this resistor. Now that is equal to the voltmeter reading of this whole branch all the way around. But now this branch on the bottom here has 2 resistors in it, and both are 8 ohms. So the voltmeter reading over this voltmeter plus the volts that goes into this resistor, both of these two added must equal the voltmeter reading of the top branch, because our rule says in V in parallel, V total equals V1 equals V2 equals V3. So they must all read the same. So if we can calculate the total parallel voltage, then we know what the voltage is over each branch in this parallel part. So let's do that. How are we going to do this? Let's see. Again, we must match variables. So if we want to work with V parallel, we work with the total current flowing through the whole parallel part from the start to the finish, total I, times R parallel. It's very important that you see that V parallel and R parallel must be used together, as well as the total I. So V parallel equals, we already know the total current. We calculated that in the previous question. There it is, the 2 amps. So we're going to substitute 2 into I. We already know R parallel because we calculated that in the previous one on our way to the effective total resistance. So R parallel is 3.2, and we are going to substitute that into R parallel, 3.2, and if we multiply those two, you get 6.4 volts. But now here's the tricky part. That 6.4 volts is for the whole branch, from start to finish. But this branch contains 2 resistors, and the voltmeter that they're asking for, the volt reading that they're asking for, is only over the first resistor of the 2. And because they are in series, these 2 added must give 6.4. So if they equal resistance, that means equal voltage, and we can just divide the 6.4 by 2. So V over the 8 ohm resistor will be equal to 6.4 divided by 2, and that is 3.2 volts. Okay, I'm going to return now to the previous question. One of the learners asked that I must do number 1.3 again. I hope it's this one that you were talking about. It's a bit messy now after I've written all over it, but here we go. 1.3 says the potential difference across the parallel resistors. So my point here was, let's just first see what we've calculated before. Voltage and internal voltage. It's exactly the same as resistance. The internal voltage is the volts that is lost because of internal resistance. This resistance, this 1 ohm resistance, is inside the battery. And if I had a little mini voltmeter that I can put over the battery, this would read the internal voltage. Or in other words, they also use V lost. V lost and V internal is exactly the same thing. So how do all these things fit together like the pieces of a puzzle? If we take a voltmeter and we put it over, let's make this V1, and we take a voltmeter and we put it over ohm resistor and we make it V2. How would these add up? If I take the voltmeter reading over the 4 ohm resistor, in other words V1, and I add V2 to it, it will not yet give 14. It's not going to make the total. I must take V1 plus V2 plus internal voltage, in other words V lost or internal volts. So my V external is from the start of the battery on the outside, the external circuit. So I go from the start of my battery all the way around my external circuit. How much volts are given to this one? I take that. Then I go around. How much volts are given to this one? I add that. Then I get to my battery again. Stop at the end of my battery before the internal resistance. That is my external voltage. External volts of the external circuit. Now when I go and I pass my internal resistance, that 1 ohm, I can calculate how much volts go into the 1 ohm, and that is internal volts. And if I add my external volts to my internal volts, then I will get 14 volts. So I hope that clarifies that. We have another question. Please repeat 9.3 and 10.2. Let me just quickly find them. 9.3, here we go. Okay. 9.3. Let me just finish this so the learners can write it down. So EMF is equal to V external from the beginning of the battery all the way around on the outside. I add that one plus that one, that's V external, plus V internal, which is then over the internal resistance. Alright, so let's look at number 9.3. Someone asked that we would repeat number 9.3. There's question 9. Okay, let me just get a clean piece of paper. 9.3. Let's quickly see what we have calculated before. We calculated that R parallel is 3.2. The external resistance is 5.2. So in other words, we just did that. External resistance would then be from the start of the battery all the way around on the outside, that volts. Then when I get to a split in the road, I choose one of the branches and I add that voltmeter reading. So this volts plus, let's choose the first branch, plus those, go around, stop. I'm at my battery again. That would be external voltage, and then there's my internal. Alright, so let's see. R parallel, 3.2 ohms. R external, only the external without the internal resistance, 5.2. Then we added internal resistance to get 6 ohm. Then the reading on the ammeter, we calculated with EMF equals I, R plus R. EMF is 12 volts. I was being asked. 5.2 was external resistance. 0.8 was internal resistance. And we solved it to get 2 amps. Now number 9.3 is asking for the reading on the voltmeter. So 9.3 asks for the reading on only this voltmeter. But before we do that, we must first calculate the volt reading of the whole parallel part. Because we don't have separate information. Yes, we can go and calculate it, but then you have a much greater chance for error. So use what you have and go from there, because then we can mark with your mistakes. Let's do it on the same page. Now, what I said, what's very important is, if you want to calculate V parallel, you have to work with I total times R parallel. It stays V equals IR, but you must match the variables. Parallel goes with parallel, and then you must know it's the total current that flows through there. It's from before the split in the road up to after the split in the road. This whole parallel part we can do calculate the voltmeter reading. So we already have V parallel. We calculated it in the first question. There it is, 3.2. So if I say that's R parallel, sorry. We have total I. We calculated that in the second one. It's 2 amps. We already have R parallel. That in the first one, 3.2. That gives 6.4 volts. That's the easiest way of doing it. But now we're not done yet, because that is the total V from there up to there. This whole thing. That's not what they're asking. They are asking, what is the value of this voltmeter reading? Now you must see that the second branch has 2 resistors in it. One 8 ohm and another 8 ohm. And this voltmeter is only takes the reading of one resistor, not both, not the whole branch. If they asked the whole branch, then your answer would just be 6.4 volts, because that is the reading of the whole parallel part. But now they're only asking one resistor. So because these 2 resistors have the same value, they are going to split the voltmeter reading in 2. 3.2 volts go to this one, and 3.2 volts go to this one. So to get the V over the 8 ohm resistor, we're going to say 6.4 divided by 2, and that gives 3.2 volts. Because together, this one will give 3.2, that one will take 3.2 volts, and together they must make up the whole voltmeter reading of the whole branch, which is 6.4. And then I have to go back to number 10.2. Let me just find it real quick. Alright, question 10.2 And you can expect this one in your matric exam. It's one that they always put in there. They love asking this one. So go and practice these. Take the memo, download these things from the internet. You take old papers. Ask your teacher for old papers so you can work through these and have examples, because they ask this one every year. So make sure that you do examples of this one. Let's quickly see what they're asking here. Whenever they change something in a circuit and they ask you what will happen to V, that's how you know it's the 4-variable one. When they ask you what will happen to the reading on the voltmeter if this and this and this happens, then you know, I must look at my 4 variables. R, I, V lost, V external. V external. Once you see that they changed something and they asked you how does that affect the voltmeter reading, then you write down your 4 variables and you go and check them from the top all the way to the bottom. And as I said already, if this one goes up, that one will go down, down, up. If that one goes down, down, up, up, down. It always works like that. These two have different signs. These two do the same, and these two are doing different things. So let's see in this example. They say we take out the 9 ohm resistor and we put in a wire with no resistance. So what you're doing is you're forcing all the current to only take this path, because that path is too hard. There's too much resistance there. This path, this branch here, has no resistance. So all the current will take this path after you have changed your circuit. So current is going to go around from your battery around. It's going to come to the split in the road. It's going to see there's no resistance in this one, and there's a lot of resistance in that branch. So we're going to take all the current is going to go down this wire right here. So if all the current goes down this wire, what happens to your total resistance? It gets less, because these two resistors don't exist anymore in this circuit. Okay, so it's going to go all the way around the battery, go through the internal resistance, go around, and it's only this 2 ohm resistor that's part of the circuit now. So what happens to your total resistance? It becomes less. So now let's get that starting point, then the rest is easy. Because when resistance become less, what happens to I? We see it from Ohm's law, V equals IR. When R goes down, I goes up. So I goes up. And this is a rule, this always happens. When R goes down, I will go up. Okay? When R decreases, I will increase. What happens to I? Happens to V, because the I flows through the V, and from V equals IR, I and V is directly proportional to each other. So if I goes up, V will go up. So V lost will go up. These two will always have the same sign. These two will always have different signs. And then these two will also have different signs, because V lost plus V external has to give the EMF, which is a constant value. So V lost plus V external must equal EMF. So if V lost goes up, that means V external must go down. So adding these two will still give me this constant value of EMF. And now you must just go and write it in the correct order and not with arrows. You're going to write it in words. So first we must answer the question. The question says, how will the reading on the voltmeter be affected? Now, how will the reading on the voltmeter be affected? It will decrease. V external is the reading on the voltmeter. V external, if you look at this on the drawing, V external is the reading, this reading on the voltmeter right there is V external. And we said that V external will decrease. Then you write V external will decrease. And now you give your explanation that they ask for. Explain each answer. Then you start at the top. R will decrease. Current will increase. V lost will increase. Therefore, V external will decrease. And you get your full marks. And how do I study these things? How do I study electrical current and circuits and all this? By practicing. It's not going to help if you open your textbook and you just read through it and say, yes, okay, now I'll be able to do this one, this will be fine. You take a question, you read it, you take a page, you do the question. You don't look at the memo. You do the question, then you take a red pen and you go back to the memo and you mark and you circle your mistakes so you don't make them again. You don't just read through a memo because you don't learn anything by doing that. You don't read your definitions. Oh yes, I know they won't ask this one. You don't read through them, you write them. You make a definition book. As you study, you write your definitions down. Then you start memorizing your definitions from the textbook. Not your own story, from your textbook. And then you go and practice. You practice, practice, practice. Hours of practice for all this. Good luck to each and every one of you. I know you will do well.